All right, our next lesson is on evaluating expressions. We have already talked about using variables and we've talked about order of operations, and this lesson will combine those two concepts together. So let's first understand that to evaluate an expression simply means to substitute a given number for a variable. So it's like you're going to be given a key for x and y. You'll be told what x and y stand for. And then you're going to use what you know about order of operations to help simplify that expression. So, for example, here's what you're going to see in the homework and in any classwork practice problems that you do. You'll see directions that look like this. Evaluate each expression if A equals 5 and B equals 2. So you're given a key for what those A and B values actually stand for. You're then going to rewrite the problem in place of the variables, like I'm about to model, and then you're going to simplify. So, for example, here are 3 different problems. In the first example, we've got A plus B. In your head, you might very easily just know that 5 plus 2 is 7, but my expectation is that you're actually going to rewrite, as I said here, that since A is 5, and B is 2, you're now rewriting the expression using just numbers. 5 plus 2 we know equals 7. No equal signs because these are expressions and not equations. And underneath it, we're going to answer that 5 plus 2 is 7. All right, an easy one-step example. The next example, 3A plus B. What does that really mean? 3 times A plus B. So watch how I'm going to fill in the next step. Typically what I will do is I'll use either parentheses or a raised dot. So 3 times 5 plus 2. I'm expecting that you're going to rewrite that step. As an alternative, if you wanted to write 3 times 5 plus 2, that would be okay with me. Since this is a multi-step problem, I'm not going to do it all in my head in one step. My very next line is going to look like this. We know that 3 times 5 is 15. So I simplified that part of the expression, plus 2. And now I'm ready because there's just one step to answer the question. And 17 is the answer. All right? So this step, optional which way you want to show it. The second step, and then finally the answer. All right, same thing for the last problem on this page. A plus 4B. Let's remember that means A plus 4 times B. So I'm rewriting 5 plus 4 times 2. Again, if you're using a raised dot, that's fine. I see here that I have addition and multiplication both in the problem, which makes it a multi-step problem. So my next line isn't going to be my answer yet. My next line is going to just be going one step at a time. 5 plus 8, following my order of operations, and now I'm ready to answer as 13. So what you see here is exactly how I want you to do it in your homework and in your classwork. It is a must that you rewrite the problems first using the numbers in place of the variables. All right, the next page is going to get just a tiny bit more complicated. We're still evaluating expressions. And this time we're going to try it with 3 different values. So here we've got evaluate each expression if x equals 2, y equals 3, and z equals 4. Remember that evaluate simply means to substitute, and then we're going to simplify using our order of operations. So I've got 2x minus 3. My very next line is going to look like this. 2 times 2, because 2x means 2 times x, minus 3. It's a multi-step problem, so I have one more step before I answer it. My next line is 4 minus 3, and we all know that 4 minus 3 is equal to 1. Second example, x, y plus 4. x, y means x times y plus 4. So my next line is going to show 2 times 3, and again, you can use parentheses or a raised dot there. There's x times y, 2 times 3, plus 4. It's a multi-step problem. The next line should simplify it down to 6 plus 4, and 6 plus 4 will give us a value of 10. Again, notice there are no equal sign, none of those little pyramid, arrow things, any of those order of operation no-nos that we talked about. And then finally, 10 minus z, 10 minus 4. I'm okay with you not changing this to 10 plus negative 4, but if you want to, that's always okay, because by definition, subtraction means adding the opposite, and 10 minus 4, it's one operation, so it's one step, gives us a value of 6. All right, the last 4 problems here are going to involve some exponents. And remember what we talked about with our order of operations. Exponent does the math only to what is directly to its left. So let's look really carefully in each of these problems as to what number or what part of the expression the exponent has the power over. X squared plus z. If x is 2 and z is 4, my next line is going to look like this. And I almost always, and you'll see why when we start getting into negatives next week, I almost always will put the variable in parentheses. Because these are all positive values, it doesn't really matter yet, but it's not a bad thing to get in the habit of doing. So I've got 2 to the second power plus 4. We know that 2 to the second power means 2 times 2. So 4 plus 4 to give us a value of 8. Even though in this line here we only see one operation, the addition sign, we have to remember that the exponent is an operation. So we've got one more step to go before we solve. Right, the second example is going to be pretty similar. We've got y squared minus 2. So that means that we're doing 3 squared, or 3 to the second power, minus 2. 3 to the second power, remember, isn't 6, because we're not saying 3 times 2. We're saying 3 times 3 to get 9 minus 2. And 9 minus 2 is 7. Okay. So you know, for each of these problems, 2 squared and 2 squared, they mean the same thing. So if you're not yet using parentheses, it's okay. I'm just sort of forewarning you that when we get into some of this exponent stuff with negatives, you're going to want to use parentheses. So for now, if you're writing 2 squared or 3 squared without parentheses, it is okay. All right, last 2 problems. X plus y squared. We've got 2 plus y is 3, so we've got 3 to the second power. 2 plus 9. Even though 3 times 3, mental math, we're still going to write that step, and 2 plus 9 gives us a value of 11. All right, the last problem. Notice that the exponent is outside of the parentheses. So when I look to see what is to the left of the exponent, to the left of the exponent is parentheses, which means that that exponent has the power of everything you see inside of parentheses. So I'm going to follow my order of operations, and I'm first going to fill in x plus y, that's 2 plus 3 to the second power. What I'm squaring is going to be the sum of 2 and 3. So we know that 2 plus 3 is 5. 5 to the second power isn't 10, but 5 times 5 is 25. All right, that should give you all that you need to do the rest of the work that I have assigned, and we will continue to review all of these concepts in class next week. All right, take care, everyone. Bye-bye.